Hello, it's Pierfelice Ciancia speaking from Freegard Engineering.
In this presentation I will talk about model-based systems engineering, and I will show you an example of top-down approach from business processes to definition of system architecture, going through the system functional analysis and the definition of system requirements. Business processes describe interactions between actors and/or organizations on a business level. Examples of business processes in the medical technology domain are interactions between patients and doctors during therapy processes, or even customer care processes or maintenance processes. In order to carry out all the activities in those processes, one or many different systems can be used, and at this level, stakeholder requirements for the system of interest or for the system of systems can be derived. Business processes lead us to the definition of the system context, and use cases can be directly derived by activities which are carried out with the system of interest during business processes. During the functional analysis, we aim to define functionalities and system requirements, and functional requirements can be traced towards use cases. Further, test cases can already be defined at this level. Traceability between requirements can be performed by the use of different methods and tools. Examples are traceability matrices or requirements diagrams. In this slide, I show you an example of traceability between use case, system requirements, and test case.
It is possible to define test cases in a very early stage. Verification of requirements has to be systematic and repeatable, and the reuse of behavioral diagrams can be guaranteed. In this slide, I show you an example of test case described by the use of an activity diagram.
System requirements can be grouped under the definition of functional blocks. These functional blocks will be then part of the functional architecture. Here you can see an example of system functional architecture where functional blocks are part of it. And here you can see the interfaces between functional blocks in the architecture. Last step of the top-down approach is the definition of a system logical architecture, which satisfies system requirements, of course, and where all functional blocks are allocated to logical elements. In a model-based systems engineering perspective, the model is leading the development of a system during the whole life cycle, from the concept phase to the disposal phase. All stakeholders can refer to the model for sharing information between them in order to have a common language. Who is responsible for building the model is the system engineer. Back to the first slide, the way we define the top-down approach is starting from business processes, going to the system functional analysis, to the definition of system requirements, and to design of a system architecture. All these steps can be covered by the use of a model-based systems engineering methodology, which is an iterative process, where the definition of a system architecture will influence the definition of a system requirement, and vice versa.
It is possible to use a top-down approach with a system of systems. From business requirements, we can go down to the system of systems architecture and further to single systems architectures. Each system will have its own stakeholder requirements and eventually its own business requirements. The same steps are repeated at each level and for each system, so this approach is characterized by recursion.
But also by iteration, because this model-based system of systems engineering process is made up of single model-based systems engineering processes. So once again, iteration and recursion characterize the system of system engineering process. The iteration is between the steps in the top-down approach, and the recursion is because we use the same approach for each of the systems. Coming to conclusion of my presentation, Here you can find a summary of the steps of the top-down approach, which can be used in order to define a system architecture which satisfies given business requirements. This approach is domain independent and it can be applied to systems or to system of systems. And the system of systems engineering process is characterized by iteration and recursion. And a model-based systems engineering methodology can be used. Thank you for your attention.